Council identified that we needed more connections for pedestrians across our river in the downtown, and that they would be of high quality. So they would be landmark bridges that would be beautifully designed and worthy of our beautiful Bow River. And so the St. Patrick's Island location was identified very early on. And then we went to competition, and we had many applications, some really extraordinary ones from international architects, and this bridge was ultimately chosen.
Well, the bridge is just east of the existing Langevin Bridge. It's 190 meters long approximately and consists of 3 arches, the length of which is governed by the width of the river and the width of the island. And the 3 arches are meant to represent a stone skipping across the water. It was a large project and a very interesting project, and it was designed by an engineering firm from France, and been challenged quite a bit with some of the construction and some of the issues we've had during the construction.
Some of the challenges in the shape are also some of the great parts of the project, but some of the challenges that we've had are trying to figure out how to actually build this beautiful thin structure. So as a concept, we all fell in love with it. It was a beautiful project and we all wanted to build it. And then came the hard part. How do you build it?
Well, the arches, of course, are steel, and the arch supports or the cables are stainless steel. The deck, bridge deck and footings are all concrete, reinforced concrete. And the railings on the bridge are stainless steel. So basically it's steel, stainless steel and concrete.
So the first thing you had to do was create a support for the deck and then build the deck upon it. So we had these big strong girders, big beams that spanned the river. We have an active river underneath this bridge when we're building it, so it's not like we could fly in a completely pre-made solution. We had to do it bit by bit and break it down into segments.
The deck was cast right in place, so we actually had to build temporary bridges across the river, which were the blue girders we called them. So we put piling into the ground, put the temporary bridges across, set scaffolding and poured concrete in place for the bridge.
So the arches came in first, and then the deck along a similar timeline as the arches actually, and then what happened at the end was the connection of the two. So we had two, the thin deck membrane and then the steel arches. And we had to connect those two with metal cables. And that was the last step, was to connect the thin floating deck with the large steel arches.
The arches were manufactured in Montreal by a company called ADF and transported to Calgary on trailers. There are 2 pipes basically with a plate top and bottom that were all manufactured and then spliced together on site here. We had as many as 8 welders on site, sometimes welding the splices together.
When you connect the steel arches to the thin deck with metal cables, what happens is the deck lifts just a little bit, and then we were able to take out all the supports that happened underneath it, so that we actually have the deck supported by the arches. It's a very intricate, highly connected system.
The cables were set to a pre-tensioned nominal amount, all of them, at the exact same amount, and then we again lowered the bridge slowly, and I mean slowly. We went around and lowered it by 5mm increments until it was all the cables were all taking load, and we monitored the cables and made sure that the cables weren't getting overloaded.
One thing that's interesting about the bridge construction is that we had to build into the river basin to construct the bridge, and now we're moving out of the river. So we have to be careful of fish windows when we do that, all regulated by the province, and make sure that we're aware of all of our surroundings. But it was interesting to watch how we had to populate the river and then kind of move out of it as we're moving towards the end of construction. It looks very simple, but anything that looks simple is actually never simple. Anything that looks simple is actually usually pretty complicated.